Hello there, Mr. Sutton here, bringing you the IM3 Chapter 2, Quiz 2, Extra Practice Number 4 solutions on reviewing factoring completely. There's a puzzle that goes with this. Let's go ahead and take a look at that. So here's the puzzle that goes with that extra practice. In this one, we have to factor each polynomial as completely as we can, and then find the answer in the answer column below here. So questions 1 through 7, we're using these answers on the left. 8 through 14, we're using these answers on the right. So once you find an answer, like let's say, for example, you do number 1 and you get the answer n. It's definitely not n, but let's say it was. Then you would go down below, and in spot number 1, you would put that letter, n, or whatever letter it is. So that's how we're going to proceed. Let's see how this goes. Here's our opening problem. Taking a look, this doesn't look like a super quick factoring problem. I've got a 3 out in front of the first term, but I do notice that I can take out some common factors. For example, 3, 21, and 30 are all divisible by 3, so I can take one of those out. And these each also have at least x to the first power, so I'll take an x out as well. So 3x cubed divided by 3x, that's going to be, let's see, x to the second power, subtract the exponents. 21 divided by 3 is 7. And then x squared divided by x is x. And then finally, 30x divided by 3x, that'll be a plus 10. So on this inside stuff, I do have an x squared coefficient of just 1. So I can do the easy kind of factoring and just ask for factors of 10 that add up to 7. So 1 and 10 won't do it, but 2 and 5 does if they're both positive. So I've got the 3x I took out in the beginning, and I've got an x plus 2. And an x plus 5. Looking for all that over here on the left, I've got a 3x, x plus 5, x plus 2. Looks like r is what I'm looking for. So that goes in spot number 1. So there's 1. And then I'm just going to double check and make sure I don't see any other 1s around here. It looks like I don't, but we have to be careful because some of these get repeated. For example, it looks like 4 right there ends up twice in the puzzle. So let's just keep our eyes peeled for duplicates. For the second problem, we start off with an x to the fourth, which is kind of weird, until we notice that all the terms have some kind of x in them, including this last one, which has an x squared. Since that's the lowest exponent, I can actually take that out, x to the second power. And that's going to leave me with x to the 4 minus 2, so x squared, plus x to the first, minus 56. And now I'm going to be looking for factors of negative 56 that add up to the 1 that's invisibly next to my x here. So 1 and 56 doesn't work, 2 and 28 is no good, 3 doesn't go into 56, 4 goes in 14 times, but that's still not going to get me 1. 6 doesn't go into it because 3 doesn't. How about 7? Oh, 7 times 8 is 56. If I have negative 7 and positive 8, that adds up to my positive 1 here. So I've got x squared, I've got x minus 7, and then x plus 8. And looking for those factors over on the left, I've got, let's see, here's an x squared, x plus 8, x minus 7. There we go. Let's go with A, and that's going over here in spot 2. On this next problem, I noticed that I've got 4 terms. Can't take any common factors out of all 4, but I can use grouping on what I've got here. So for my first 2 terms, it looks like I have an x that I can take out of those. That leaves me with an x plus 5. And then the next 2 terms, those both have a y that they can contribute. So take out a y, leaves me with x plus 5. X plus 5 can come out of everything. And then I just have an x plus y left over for the last factor there. So looking for x plus 5, x plus y. Looks like that's the second option here, n. So I'm going to put that in spot 3, and it looks like that's the only 3 out there. For this next one, it's looking like I could take an x out of both of those, and also I could take out a common factor of, let me see, I think 4. 4 is probably as good as it gets. So take out a 4, take out an x. 36 over 4 is 9. X cubed over x is x squared. And then 64 over 4, that's going to be a minus 16, and the x's cancel completely. So I've got my square root shortcut that I can use here. A squared minus b squared, that's this 2 perfect squares in here. I can square root each of those. So I've got the 4x initially that I took out. Square root of 9x squared is 3x. Square root of 16 is 4, so plus 4, and then 3x minus 4. Looking for all that over on the left, looks like I've got option T right here. So that goes in 4, and also at the very end we've got another 4, so we get to use that one twice. For number 5, I can't take out any common factors. However, I've got 4 terms already, so I can try grouping this one. First 2 terms, it looks like those have an x that they can both get taken out. So we have an x squared turning into an x, and this xd term is now just going to be a minus d. For the last 2 terms, definitely I can take out a 7. So that leaves me with an x and a minus d. X minus d is our common factor that we can take out of everything. And then we have leftovers of x plus 7 going into parentheses next to it. Let's see if I can find that now over here on the left. X plus 7, x minus d, there we go. We've got an s. That's going in number 5. For this problem, looking for common factors, I see that I can take a 5 out of all 3 of these. So taking that out, we've got 35 divided by 5 is 7, and an x squared is still there. 100 over 5 is 20, so negative 20x. And then 15 over 5, that's going to be a negative 3 for that last term. Nothing special going on inside the parentheses. I can't use a square root shortcut or anything like that. So I'm going to go straight to AC method on that stuff inside. 7 times negative 3 gives me an AC value of negative 21. And now I'll be looking for factors of negative 21 that add up to negative 20. Well, how about 1 and 21? Positive 1, negative 21, or negative 20 rather, negative 21. I was right the first time. That would do it. So I'm going to split up that negative 20x into a plus x minus 21x. That was my only change between these 2 lines here. And now I've got some 4 terms in here that I can use some grouping on. This 5 came out in the beginning. I don't want to lose it. I'll just leave it there. Now for the first 2 terms in our big parentheses, 7x squared and x, I can take an x out of both of those. So that'll leave me with 7x plus 1. And for negative 21 and negative 3, I'm going to take out a negative 3. So that leaves me with a positive 7x and a plus 1. Let me keep my 5 out there. And now the 7x plus 1, that's a common factor that comes out of everything. And then finally, x minus 3, that's my leftovers for my other factor. Can I find that over on the left? Well, there's the 5. There's the 7x plus 1 and the x minus 3. Looks like we've got everything. So number 6 then is going to be an E. So there we go for 6. For this problem, I see that I've got 4 terms, so I'm going to try grouping on this. First 2 terms, I've got an x that I can take out. So if I do that, I have a y and a plus 8 left over. My third term's negative, so I'm going to take a negative out of the next 2 terms. These both have a y that they can contribute, so let me take out a y. Negative y squared then becomes a positive y, and then negative 8y divided by negative y is positive 8. So that means that y plus 8 is a common factor coming out of everything. And then my leftovers, x minus y, going right next to it in the parentheses. Looking over here, we've got x minus y and y plus 8 for choice F. So then number 7, of which there's only 1 right there, is getting an F. For this problem, I've got 3 terms that are all divisible by 2. So let me start by taking a 2 out of all that. And I also notice they all have this random a kind of hanging around. So I'll take that out too, because I don't want to mess with it later. So that leaves me with x squared for my first term. All the a's are canceling. Next term, we've got negative 22 over 2. That's negative 11. And we didn't take out any x's, so negative 11x. And then finally, 60 over 2 gives me a plus 30 there. So for this inside stuff, I have a 1x squared situation. So I'm just looking for factors of 30 that add up to negative 11. So 1 and 30, 2 and 15, 3 and 10, none of this is really working. 5 and 6 adds up to 11, negative 11, if 5 and 6 are both negative. So let me use that. The 2a I took out initially, I'm going to keep that around. And I'll also have x minus 5 and x minus 6. Let me see if that's over on the left. Sure is, choice H. So we're going to put that in spot number 8, which is right there. and that's the only 8 out there. For this problem, we have x to the fourth minus y to the fourth. Now this is basically the difference of two perfect squares. So I am going to use my a squared minus b squared equals a plus b a minus b perfect square shortcut. Square rooting each of these things, square root of x to the fourth is going to be x squared. We divide the exponent by 2 when we square root. So we have x squared plus the square root of y to the fourth, which is y squared, and then x squared minus y squared. Unfortunately, I can't just stop here. I have to keep going. X squared plus y squared, we can't do anything with that because it's not the subtraction, it's the sum of two perfect squares. So that just gets carried down. But now this next one, x squared minus y squared, it's literally an a squared minus b squared kind of situation. So we have the square root of x squared, x, plus the square root of y squared, y, and then we also have x minus y. Looking for that now, I see that right over here in choice U. So let me put that next to the 9 all the way at the end. For number 10, I've got 4 terms and no common factors that I can take out of everything. So let me go straight to grouping on this one. First 2 terms, x cubed minus 9x. I can take a 9 out of those, or an x rather, not a 9, an x. That'll leave me with an x squared minus 9. For the next 2 terms, I can take out a 5. That leaves me with x squared minus 9. My x squared minus 9 is a common factor that can come out of everything. And then x plus 5 is our leftovers that we'll put next to that. Now I'm not quite done. This x squared minus 9, that's the difference of 2 squares. So I can use my a plus b, a minus b shortcut to factor that a little bit further. Taking the square root of x squared, I've got x plus the square root of 9, which is 3. And then I also have x minus 3, a minus b. And then don't forget about this x plus 5 that we got on our last step with the grouping. So looking for those 3 factors, I think I've got them. I had something close in choice B, but not quite. Down here, choice I, x plus 5, and then the x plus and minus 3. There's everything I need. So I'm going to put an I in spot 10. So get an I over there. And we actually have another 10 over here, so I get to use that I twice. And now I'm ready to move on to the next question. For number 11, I've got 4 terms, no common factors for all 4 of them, so let me just go straight to grouping. For the first 2 items, I can take out a 2 for the 2 and the 8. I can also take out an A, because those both have A's in them. And I don't want to be greedy, but it looks like they also have X's, so let me take one of those out too. So this 2ax squared, now that's just going to be an x term. And then 8ax divided by 2ax, that's going to be a plus 4. For my last 2 terms, x and plus 4, I can't take anything out of those except for a 1. So I'm going to do that because I got to take out something if I'm using grouping. That leaves me with what I started with, x plus 4. But now that x plus 4 is a common factor that can come out of everything. And then this 2ax plus 1 goes next to it in a parentheses. So 2ax, there's a 2ax, but it's got a minus 4 instead of a plus 1. So let me keep looking. Up here, actually, the very top, 2ax plus 1, x plus 4, that's what I need. So I'm going to put a D under 11. And that was the only 11. You will notice, however, that all the remaining problems, 12, 13, 14, they will all get used twice once you find the answer. For number 12, we have something that looks kind of like a quadratic, only it's got x to the 4th, x squared, and a constant, instead of x squared, x, and a constant. We can actually treat it like a quadratic and try to factor it, though. We'll just have to remember to use x squared instead of x when we do so. So let me look for factors of 100 that add up to negative 29. 1 and 100 won't work, 2 and 50 is no good. 4 and 25 works if they're both negative. So I'm going to write not x, but x squared minus 4 and x squared minus 25. That'll get me the x to the 4th when I multiply this back out. Now I'm not quite done factoring because these are both differences of squares, so I can use my a plus b, a minus b shortcut that I use whenever I see an a squared minus b squared situation. For my first parentheses, the square root of x squared is x, so we've got x plus the square root of 4, which is 2, and then x minus that, x minus 2. For the next one, I have the square root of x squared again, x, plus the square root of 25 this time, so that's 5, and then x minus 5. So that's pretty easy to spot. I think this is the only one with 4 items, choice L. So let me put that under spot 12. So there's an L, and actually here's another L. We get to use that one twice. Problem lucky number 13. For this one, we've got 4 terms, so I'm thinking factoring by grouping is a good way to go. The first 2 terms both have a y squared, so I'll definitely factor y squared out of there. That leaves me with an x squared and a minus 1. For the next 2 terms, since my third term's negative, I'm going to take out a negative, and 15 looks like the number to go with here. So that'll give me an x squared and a minus 1 again. So x squared minus 1 is my common factor that can come out of everything. And then I have a y squared minus 15 left over for the other factor. But now this x squared minus 1, that's an a squared minus b squared kind of situation. So I can factor that into a plus b, a minus b kind of thing by square rooting. So the square root of x squared is going to be x. Square root of 1 is 1. So we have x plus 1 and then x minus 1. And then don't forget about the y squared minus 15 that we had before. So looking all that up, I see here's the y squared minus 15, but I've got different factors next to that one. Going a little higher up, here's y squared minus 15 plus 1 minus 1. That's what I want. So we're putting an O next to 13 wherever we see that. Here's a 13, so you get an O, and this 13 gets an O as well. All right, we finally made it to the last problem. This one's worth 2 blanks down below, it looks like. So let's go ahead and get it started. So I noticed that all 3 of these items are even, so at the very least I can take out a 2 for a common factor. Can I do better than 2? Well, 8 goes into 56, but not 98. And 4 does not go into 98 either, so yeah, it looks like 2 is as good as it gets. Now, since each of these have at least x to the second power, I can take out an x squared as well. 8 divided by 2 gives me a 4. X to the 4th over x squared is x squared, 4 minus 2 there. And then 56 over 2 is 28. X cubed over x squared is x. And then finally 98 divided by 2, that's given me 49. X squareds completely cancel. So I can bring down my 2x squared, and now the stuff inside here, I could use AC method. However, I noticed that 4x squared and 49 are both perfect squares. So this might be one of those a plus b squared parentheses sorts of shortcuts that I can use. Let me try out this shortcut and see if this is actually what I'm dealing with. So the square root of 4x squared, that would be 2x. Square root of 49 is 7, and since my middle term is positive, I'm going to have a positive 7 in there, and then that would be a squared parentheses. But now let me multiply 2 times 2x times 7 together to make sure I really do have this 2ab situation going on here. 2 times 2x is 4x. 4x times 7 is 28x. That lines up with what we had here, so this is actually the correct factorization. Saved a whole bunch of time on AC method there. Looking over on the left to see if I can find that, I've got my 2x squared and my 2x plus 7 quantities squared. So that's going to be a W going in the 14th spot. So that goes right there. And also another one for the last spot, 14. Now that I've got all these letters filled in, let's see if I can solve the riddle. What happens to people who don't know toothpaste from putty? So we have there. And then this next word looks like windows fall out. Their windows fall out. Well, that's not especially deep or profound, but hey, we solved the puzzle. So till next time, this is Mr. Sutton signing off.